the definitions of real numbers, and I have a little chart for you guys too. And in class, we're actually going to discuss the bag method too that I like. And if you guys want to make those bags, just let me know, and I'll get you guys what you need on that. This pretty much shows me everything I need to know. Okay, so first of all, if in order to be irrational, I have to be a number that goes on and on and on, that never repeats and never terminates, right? Two things. It never repeats and it never terminates. All right? If I'm irrational, I cannot be rational. All right? Does that make sense? Okay, good. Because doesn't ir mean the opposite? Yeah. So if I'm irrational, I cannot be irrational. So the very first thing, if I was looking at to classify a number is, first of all, is it a decimal? And if it is a decimal, then does it repeat? Because if it repeats, then it's going to be rational. Does it terminate? If it terminates, it's going to be rational. Okay? But if it doesn't, then automatically it is irrational. Okay. Well, let's say I was trying to classify a number such as 1. Notice how 1 is a natural number. Yes? But these natural numbers fit in the whole number. So 1 is also whole. It is also an integer. It is also irrational. Notice how it's in all of these circles. Okay? So I can go out, but I cannot go in. I'm going to discuss that. So look at this as being 7.12 repeating. Notice there's a bar over here. I know it's not a lot of you guys' work that you actually are putting a bar there. That is awesome, awesome, awesome. Okay, so we got 7.12 as being repeating, so we know it's rational. But is it an integer? No, because integers cannot be decimals. Okay, so looking at this, 7.12 is only in the irrational circle. And if you notice too, where is it at? It only fits in the rational. Okay, but let's look at 0. 0 is a whole number, right? Okay, what else is 0? 0 is an integer, because whole numbers fit inside the integers. 0 is also what? It is also rational, because integers fit inside the rational. But is 0 a natural number? No, it's not. 0 is not a natural number because whole numbers don't fit inside the natural number circle. Make sense? Let's look at -2. -2 is an integer. Totally agree with you on that, right? Okay, what else is it? Good, it is rational because it fits, the integers fit inside the rational circle. Is it a whole number? Nope. It's not a whole number because I cannot go backwards. And if you look at this, the integer circle does not fit in the whole number circle. Is -2 a natural number? Nope. Because the integer circle, again, does not fit inside the natural number. So, let's say I say this, and be careful with what I'm saying. Are all rational numbers integers? Are all rational numbers integers? No. They're not. All rational numbers are not integers. Okay? Because of -9 over 2, 7.12, 11.23, 3/4. Those are all rational numbers, but they're not integers. Okay? So, my second question. Are all integers rational numbers? Are all integers rational numbers? And if you said yes, you're totally correct, because all the integers that we have in here fit inside the rational box, right? So all integers are rational numbers, but all rational numbers are not integers. Got that? Okay, so let's do some classifying. Remember we said the word subsets? All these guys are subsets of real numbers, because we're talking about real numbers right now. Real numbers is our set. All these guys are subsets. So what are the subsets that these belong in? And if you need to revisit this chart during this time, please feel free to. Okay, so let's see here. -5. Well, we know that -5 is an opposite, so it's an integer, right? So -5 is an integer. So if it's an integer, it also has to be rational. Okay, can it be anything else? Is it a whole number? Nope, because I can't go inside. Is it a natural number? Nope. Is it irrational? Nope, because I can't be rational and irrational at the exact same time. Okay, so -5 is an integer and it's rational, and for our purposes we're talking about real numbers, so all these are going to be real numbers. And in order to get full points on your homework, you have got to tell me every single one of these. If you only tell me it's an integer, I'm not giving you full points. Square root of 2. Well, cool thing about this is, hey, we have it on our chart. And what is the square root of 2? It's irrational. So it's irrational. And what's also the cool thing about being irrational? If I'm irrational, could I be any of these guys? Nope. But I'm also a real number, aren't I? Yeah. So I need to put real number down here too. So it's irrational and it is a real number. Let's look at square root of 13. Hey, well, square root of 13. Let's see. Let's plug it in because I don't know the square root of 13. Square root of 13 is this. All right. Your calculator can honestly only put in so much. So when we come up to a situation like this, it's going to be irrational because, yes, it looks like it does terminate because your calculator ends at 5. However, the only reason why your calculator ends at 5 is because that's the amount of places it can actually hold in its screen. So the answer to this one is going to be irrational. It's going to be irrational. And if it's irrational, it's also what? A real number. Is it anything else? No, it's not. Okay, what about the square root of 61? Square root of 61, again, we get this decimal, and again, when it comes into your calculator, the only reason why it ends at 6 is because that's the amount of numbers it can fit in your screen. So on this one, it is going to be still irrational. It's irrational, and it's a real number. Okay. So what about this, guys? Go ahead and pause the video and work these two out. If I'm pausing the video and working these two out, aren't these guys going to be the exact same thing? Yeah. So go ahead and pause the video, work these two out, look at your chart, think about everything that we've discussed, and write your answer down. Okay, assuming you pause the video, I would hope you guys would realize that 3/4 really equals 0.75. So therefore, it is it terminates, right? It's a decimal that terminates. And what do we know about terminating decimals? Good, we know that they are irrational. And if they're rational, they're also real numbers. Are they anything else? Good, no. Because integers cannot be decimals, right? Integers cannot be decimals. Whole numbers cannot be decimals. Natural, well, I cannot go backwards, right? All right. What about 1/3? 1/3, if I put in my calculator, I'm going to get 0.3333 repeating. So what do we know about repeating decimals? Good, they are rational and real numbers. They are nothing else. Okay, they're just rational and real numbers. Okay. What about these guys? Go ahead and pause the video and tell me about these guys. All right. Assuming you paused the video and you worked on this, you would realize that 0 is a whole number. It is an integer. It is rational. And it is real. Okay. 3 is all these plus what? Good. Natural or counting. It is a natural number / counting number. Natural numbers and counting numbers are the exact same thing. They are whole numbers. It is rational. Oh, it is an integer first, huh? Integer. It is rational. And it's real. Again, it comes down to knowing your definitions, knowing how to use this chart, and once you get used to this chart, it'll be easier, hopefully. And if you guys need the bags, just let me know. And that concludes our subsets.